We're here today with Mark Thompson, Managing Director of Talga Resources. Mark, thanks for your time.
No worries, cheers.
We're here talking about some of the carbon fibre composite testing results out today. What exactly were you looking for?
Carbon fibres as people understand them in things like golf clubs are these days in planes, and it's actually mostly a resin. Looks a bit like this. It's carbon fibres, but it's also covered in a plastic, or it's embedded in a plastic resin. It's usually an epoxy. And this is actually a insulator. It doesn't conduct electricity. This didn't used to be a problem in the old days. If lightning struck your plane and it was made of aluminium, you could conduct the electricity around the plane. But these days with a carbon fibre resin plane, then you have an issue. So what they've done is they actually take this copper wire and they run that through the plastic. It's quite a messy process, and there's thousands of kilos of weight of this metal, and they're able to, then when the lightning hits the plane, it's able to conduct electricity away in a safe way without blowing holes through the fuselage or having an impact on things like the fuel, for example. So yeah, there's a few issues with that. Number one is the weight, which leads to higher fuel burn, which leads to higher emissions of CO2. Secondly, the material itself, if you break it or if you're buffing and doing a paint repair on the plane, which is very common, they damage it and it needs repairing, which is messy. And thirdly, it's actually it's difficult to lay up. So when they make the plane, it adds time and expense. So what we did was add graphene to the resin, and we made it electrically conductive to the point where it could conduct electricity strike in the plane almost as well as copper. So that was the main import of the results today. And as an aside to that, by making it conductive enough like that, essentially it makes it into a heating element. So we also did a test where we put some power through the plastic through the resin and made the plastic conductive enough to boil water. In fact, it got up over 350 degrees Celsius in points. So this opens up applications like the wind turbine market, where the blades, if they get covered with snow or ice, have to be manually cleaned. Sometimes they even have guys hanging out of helicopters spraying chemicals onto them. So in this case, you could actually have the carbon fibre blades of the wind turbines internally heated. So this makes a more economic solution and is a pretty large volume application for graphene.
So clearly breakthrough results. How do you advance these findings through into a commercial phase?
Yeah, good question. So our strategy is always to make this investment in designing the material. You'll notice that it's not actually a graphene raw product. We've actually made the resin itself. Our strategy then is to take those results to the market, and we engage with large customers, similar to what we've done in coatings and batteries and in concrete products. So we add the value. We have it's not a raw product anymore. We've actually made a conductive resin. The way we dispersed the graphene into it was quite unique. We have some IP pending in that area, and so we've created some value in that, and then we take it to the market to get the deals to advance the product. Ultimately, what that is aiming for is to create demand from our mine. So ultimately, we're trying to build the volume that's required that will underwrite the development of the full-scale mine as compared to the demonstration scale that we're at now.
Recapping on some of the recent findings of your research, touching on concrete, for example?
Yeah, that's right. Since seeing you last, we've been really busy and put out quite a lot on the product side in particular. The concrete results were outstanding. It's caused a lot of interest from all over the world, particularly in Asia actually. We really saw it as more of a Northern Hemisphere product. This is the conductive concrete, both thermally and electrically. So yeah, it's really seems to be of an age when concrete's become of great interest to a lot of companies based on the lowering CO2 emissions, but predominantly around roads, especially the charging of vehicles, either in a static or a dynamic fashion, meaning when the vehicles are moving. So with the greater electrification of vehicles, the idea of conductive concrete both to have a flat surface where the batteries in the cars are stable over charging devices, or ultimately being able to charge while they drive, which is the end goal, can be enabled by concrete. It may not be the only thing that's used, but in conjunction with copper and other things, it could play a big role. So yeah, we've had a big demand to that. We've also had a big demand from things in the coating area where we're working now. We're still working with Chemetall and some of our customers on the coatings, and that's all going very successfully. Not much we can say internally about that, but it's all going very well, and we're just about to start working on zinc replacements, where we're working on primers, large volume replacement of metals like zinc in coatings, and we're really excited about that because this leads to anti-fouling type systems and really much lower environmental impact type coatings for large volume markets, so they're going really well. The battery space is great because it's such a current product. You can do next generation, but it doesn't require a futuristic outlook for the technology. It's something that we think we can get some commercial things delivered a bit quicker, and that will underwrite the development of the lumpy ride of graphene commercialization, should we say. So together we see them as a real powerhouse team, a very, very practical way to go about getting over the line with being able to push the button on development.
And in terms of Billerud-Korsnäs, how is that relationship progressing?
Good, yeah, it's early days, but that's a significant product for us actually. Not only a very large company, but Swedish and one of the largest paper and fibre board manufacturers in the world. Again, a very green focus there, very much about sustainability of packaging. I can't give details away on that under our disclosure agreement, but very much packaging is a large volume area where there's a big push away from plastics, and to go into fibres coming from renewable pine plantations, etc., forestry products. The trick is to get extra cycles of recyclability to lower the CO2 emissions of products, but also to replace things that are currently in a can with a paper package, basically. So a biodegradable, limited lifespan product that performs really well. For example, they are in a consortium that's working on a paper replacement for aluminium cans that hold fizzy drinks like Coca-Cola. So it's pretty big to shift from canning of a fizzy drinks are hard because they're acidic and there's pressure and they're a food stuff. To replace that with a paper product, a biodegradable paper product, is quite a big goal. So the packaging industry graphene enables barrier properties in all of those products. So we're very excited about the graphene can make the products tougher, it can make them less permeable, giving longer shelf life, and even in the inks that are used, so if graphene is in them, you can have special functionality where the touch or daylight can make certain effects happen around packaging. So yeah, we're just excited to get started in the packaging business with one of the better quality players out there.
Clearly a world-class deposit in a fantastic jurisdiction, generating across a multiple stream of commercial opportunities, world-class results. Mark, exciting times ahead for the company. Thanks for your time.
Thanks, David. Cheers.